Hello there. This is my very fast introduction to energy and climate change in the context of sustainable communities. So huge topic, and I've provided you with some higher level references, but basically the purpose of this is to get you thinking about energy and climate change in the context of communities and what communities can do. So the basic outline is just how do we think about energy and climate through the lens of sustainability and, of course, resilience. What would a sustainable condition be like for energy and climate? And then I'm also going to talk about what communities are doing now and what's the sort of state of best practice. So the first thing, energy for human use is a natural resource. And I mention that just because that is the framework through which we look at energy and climate in sustainability. So the first thing is that renewable energies, solar, wind, geothermal, wave energies, they're all based on the solar income of the planet. So if you think about what that implies, it implies, well, there's only so much solar income of the planet each year, solar and heat income of the planet each year. And so in some ways, you can think of this as being a relatively finite amount of energy each year. So that's a different way, that's a way for us to think about an energy budget in relation to what we were talking about, system of capitalism, which requires growth every year. So we're going to have a tension between renewable energy being a somewhat finite resource, although we're nowhere near capturing that yet. And that's the sound of a door opening. And the total solar income of the planet. So sustainability, thinking about the future generations part of sustainability, sustainability requires us to leave as much choice or autonomy over natural resources for future generations. So strong sustainability says that we need to leave an equal stock of all natural resources for the future. So there's the implication of that is that our energy use should be all renewable sources. Weak sustainability, and these are terms developed through natural resource economics, sustainability economics. Weak sustainability says we should leave an equal productive capacity of all natural resources, all natural stocks for future generations. So in sum, the natural environment will be equally productive for future generations as it is for us. I'm just going to say at this point, in terms of climate in particular, we are not able to foresee a situation in which we might be leaving the climate as good, as stable as it has been for past generations, for future generations. So in climate terms, we're working with limiting the damage from our fossil fuel energy-based economy of the last 120 years, 200 years. So we're not going to meet, in terms of the climate quality, we're not going to be able to meet the sustainability condition of either strong sustainability or weak sustainability And this is one of the reasons we really have to think in terms of resilience. How can we leave future generations systems that are more resilient? In terms of energy, strong sustainability requires us to use only renewable sources. And there's a lot of conversation right now about whether or not this is even a possible goal. And weak sustainability also implies, because it requires us to leave the natural environment at least almost as productive as ours, we should also be really focusing on renewable resources for energy in view of the impact of fossil fuels on the climate. So there's a lot of conversation about whether or not that's possible. And one of the things that sustainability really requires us to do is to not use as much total energy as we have been doing. At the same time, I want to bring up The Wizard and the Prophet, because it's a great book title, and I'm not going to ask you to read the book, but it's been a long-term conversation in natural resource economics and sustainability economics about whether we should see things as kind of the doom and gloom scenarios, the end of this, the end of that, the end of this, or whether we should look for human ingenuity to provide us with some technological changes where we can adapt to new conditions. So the prophet says, if you think about there's books coming out, I think in the late 60s, Paul Ehrlich wrote The Population Bomb. In the 70s, the Club of Rome, of which our systems person was a part, Donella Meadows was a part of the Club of Rome, The Limits to Growth. So at the one hand, we know that we're exceeding some of those global systems. So those are prophets. And then the wizards are the people that are developing and advancing and investing in technological solutions of various kinds. And we need to look at those really carefully to see what human motivations do they allow for? What allowances are there in our technological solutions? Are we able to have societies that are equitable and humane, or are we changing the nature of ourselves as we interact with technology? So those are big questions. You might recognize them in the way people talk about social media, the way that our use of social media seems to be changing the way we interact with each other. So there's a certain part of that conversation that's, the subtitle is "What's Wrong with Kids These Days," but there's a certain part of that is what's our critical reflection about how we want to live, and how do we modulate new technologies' direction or impact on our lives. So just in terms of those two definitions I gave you earlier, a prophet will want strong sustainability. All stocks of natural resources, whether it's fish or minerals or fossil fuels or any kind of thing, natural resource that you can think of as being a productive stock, including the production of delight, if you like, as they say in economics. So environmental goods, same stocks for future generations. The wizard who sees the possibility for technological solutions will want weak sustainability. One of my environmental economics professors said, he would say that you didn't need to peat bogs. The peat bogs in Scotland, people used to use the peat to heat their homes. And so he would say that you didn't need someone to come in and say, save the peat bogs, although probably you did, but that people quit using peat bogs to heat their homes. So this week, I'm going to emphasize a little bit on the wizard side with the resources that I have. And part of the reason for that is because the wizards are doing some cool stuff right now. And the general state of the climate general state of the climate and our record so far of being able to reduce our greenhouse gas emissions, it can fill you with dread. So I think as a counter to that, I want to emphasize some of the changes that are happening while the politicians are busy trying to save the buggy whip factories. Technologies are marching on. So to get right into it, fossil fuels, there's a lot of people exhorting we must stop using fossil fuels because we are running out. We've been saying for a long time. And so the logic to that is we're running out of fossil fuels, so they're going to get really high in price, and the equity impacts of our continued use of fossil fuels are going to be unbearable. Society is going to collapse without use of fossil fuels. So if you read Bill Reese's work, or if you've seen that, about the extent to which our society has been so dependent on fossil fuels, or if you look at the transformation of agriculture from a sunlight enterprise, a sunlight-based enterprise up to about 1917, to a fossil fuel-based enterprise now, where fossil fuels are in the fertilizer and fossil fuels are in the transportation, and fossil fuels are, the industrial agriculture is highly dependent on fossil fuels. So everything, the price of everything is going to continue to rise based on the rising price of fossil fuels. But if you look around, you will see that the fossil fuel price is weirdly not rising. So when I started out, I worked in an oil company, and I did strategic planning for heavy crude oil. So like the tar sands and bitumen in northern Alberta. I did some sort of research assistant stuff in studying that business. And the price forecasts that you need to support tar sands, bitumen, fracking, they all rely on oil prices that, if the profits are correct, the oil price should be rising, and it should make all these highly expensive, all these new technologies of extracting fossil fuels that are all basically all over $50 a barrel cost, should make them all profitable over the long term. But we keep seeing, back when I worked at the oil company, this was a few decades ago, but the oil price went from $45 a barrel to $15 a barrel in 6 months. It was just blam. And right now, if you follow oil markets, which you might not if you've never worked at an oil company, right now oil prices are, they're always correcting down to a level at which those massive investments that as Canadians, I'm going to say we have, because now we have a massive investment in a pipeline, but our national economy has been fundamentally depending on tar sands and fracking and bitumen development. It's not been a stable price environment, and it's certainly not behaving as anyone in 1980 thought that it would. So I really would like you to listen to the Tony Seba video that I posted this week. It's an hour. It starts with how technological disruptions work, how they have worked, and how one would expect them to work. And it gets into the intersection of various technologies that are relevant, particularly to energy and transportation. And then at the very end, he's talking about what seems to be happening right now with oil prices and fossil fuel investments. So we're likely used to feeling like fossil fuels are inevitable for us, for transportation, for our wishful thinking, for the Canadian national economy. We would, wherever we are on the political spectrum right now in Canada, we tend to think of them as being somehow inevitable. Except for maybe some optimistic young people. For various reasons, because they're a driver in the Canadian economy, they're a driver in the Northern BC economy, they're part of many manufacturing processes. And when we look around, we appear to be dependent on fossil fuels for, well, less so in BC, but for many places across the country, fossil fuels are required for heating and cooling. A lot of people do have natural gas that they're dependent on for winter heat. Almost all of us are using fossil fuels for transportation. And they're a part of every other product system, like I said, the agriculture and things that are really fundamental. Our war against plastics. All of these imply the release of GHGs through fossil fuels, and all of them imply a fossil fuel industry that Canada is part of. So this Tony Seba video that I would like you to watch and think about whether or not it resonates with your own experience of technology. It's more likely to resonate with my experience of technology because when I was in university, I was using a typewriter for my papers. I still destroy computer keyboards. I wear off the letters. But so since I went to university, computers went from being the thing that you could have access to because everybody thought you should learn how to use a computer, so you had to get a key and unlock the room where the computer was so that you could program it, and to now where we have phones and we have massive computing power, and it's not uniformly distributed throughout society, but if you think about that technological change, in that period of time. A lot of what Tony Seba has to say about the pace of technological change really speaks to me, especially his use of the cell phone as a way of comparing what the forecasters said versus how the technology played out in society. So he's basically talking about how in 80% of the world's utility markets, so we're talking about electricity for the way we use it in BC, solar is already at what's called grid parity. So, which means it's equal to or less than the cost. Solar costs the same or less than the other sources of electrical fuel in 80% of the world's utility markets. That's already happened. Increasingly, although we have a bit of a problem here in British Columbia with our grid policies because of BC Hydro, but solar power is uniquely competitive for households because it has no cost of transmission. So the 12 cents per kilowatt, 12 cents per, I'm sorry, I forget the unit. The cost of transmission that we have with BC Hydro is in the putting up the lines and maintaining the lines through all manner of snowstorms and rainstorms. Solar has no cost of transmission, household solar or building solar. So and it works in the north, depending on the design. If you design your building in such a way that it's quite energy conserving, then you can have solar powered buildings. So in that sense, boy, I've got a lot of door sounds today in my lecture. In the sense of, as a grid fuel, fossil fuels are increasingly obsolete in electrical, as sources of electricity. But most of that Tony Seba video is about the role of electricity in transportation and how a bunch of converging technologies are also going to render fossil fuels obsolete or majority obsolete for much of transportation in a very short time horizon. Now, we're not talking about everyone buying a $50,000 electric car. We're talking about the huge falls in, the way as technologies become adopted, the prices fall, the technologies become more inexpensive. And he's talking about the conversion of some technologies, including electrical storage, batteries, the way that electric cars have basically 20 moving parts instead of 2,000 moving parts. So they are on a life cycle basis already actually cheaper, but that as these things, the uptake will happen first in cities, which is one of the things I think is interesting for us in this class. As these technologies converge and gradually take up market share for transportation fuels, what happens in a market like the fossil fuel market, which is full, that people and countries will start to compete for market share, and that price will plummet. So we'll probably be seeing what's called $25 a barrel oil for the foreseeable future. And yet, this is Tony Seba's argument, which will displace most, and Canada doesn't have very much conventional oil production left. Those are those, I don't know how much you guys know about oil production, but anyway, so tar sands will be too expensive. The shale, the fracking will be too expensive. So basically, in a full market, when you have marginal disruptions, marginal reductions in total demand, you sink back, the price falls, you sink back to those lowest cost producers, which has political impact, but at the same time, it's being replaced by a whole suite of things that are renewable technologies. So I think it's very worth listening to. The video is in 2014, so you can look up, you can compare and see how close he is to being right about the global cost of solar and the march of those technologies. We know that Tesla is releasing self-driving cars because of the people getting tickets in Alberta for sleeping while their cars went between Calgary and Edmonton. So we know that some of the things he's talking about have happened, are happening. And one of the things I think about us politically is, we have this, our national political discourse is nowhere near dealing with this level of technological and social change. So it's important to keep an ear out for the wizards. So that's my optimism. The whole well, we're never going to be able to get rid of fossil fuels for transportation thing. Well, we might not be able to get rid of all of them, but let's say we get rid of most of them, then we have a real leg up on reducing greenhouse gases enough to make a dent in fueling climate change. So yes, a sustainable condition for the climate would be no global climate change. And we passed that benchmark a few years ago, and we passed 1 degree in total global warming when we got to 350 parts per million, and now we're at 412, I think, in August, last I checked. But if we could hold that warming to 1.5 degrees Celsius, the changes will only be horrifying. Sorry, guys. We're going to have to deal with many problems, but we do have the prospect of being able to limit climate change to 1.5 degrees Celsius. It's real. It's a real prospect. And so I included some resources from the Intergovernmental Panel on Climate Change, which is the latest report, the latest big report saying, hurry up, you guys. You need to reduce greenhouse gas emissions to net zero as soon as possible. So some people, maybe 10 years, maybe 2050. I think that what I'm seeing in best practices is that people are at least now aiming for net zero by 2050. So the United Nations Climate Change Group is keeping track of what companies and communities and nations have signed on to commit to net zero by 2050. And again, very large companies have signed on to do this, not unrelated to those technological changes that Tony Siva is talking about, right? It's cheaper. So our goal needs to be net zero GHG emissions by as soon as possible. So I've put a couple of examples, and again, this is just a wildly fast introduction to climate change. And the reason I'm doing this is because I want you guys to be working on your scenarios, right? So I'm relying on your being familiar with global climate change as a problem. And all I'm saying is communities have been doing climate change planning in a couple of different ways. They do mitigation planning, which is how they reduce their greenhouse gas emissions totally, how they count them and how they reduce them. And then adaptation planning, which I think is quite a focus in one of Dr. Groth's classes. So I'll just talk about community climate mitigation planning this is the problem of how do we as a community reduce our greenhouse gas emissions. Realizing I should probably say that I think it's very important to work on this, not as households, not as, you know, I don't mean not, but I mean, I don't think we should pretend that we can all make little arcs where we, you know, little houses where we meet all our energy, food, and material needs. I think that it makes much more economic and materials use sense to be looking at our community infrastructure. How do we as a community do energy? How do we as a community address our transportation needs? Thinking of ourselves as isolated households is part of how we got into the road car problem in communities. It's part of what has been making the social fabric of communities take a back seat to where the roads go and where the parking is. So I think that communities are a really important locus of action because communities make decisions about infrastructure, roads, water, how the services are going to go, where the buildings are going to be in relation to each other. These are decisions that communities make. So land use, transportation, energy. And it's so important to do this with some economic efficiency. Because if we don't, then the privileged people are going to be able to afford their little arcs, and the less economically privileged people are going to be cold. They're going to have what's called energy poverty. They can live in the dark, and they're not going to have very good houses. So I think it's really important to work at the community level. Sorry. I'm just laughing about a new community that's proposed for relatively nearby here up a Forest Service road. And they're going to be a sustainable community that's located in the back of Beyond. Anyway, don't get me started on the equity of that, of the sort of, no, I'm not going to say that. So how do communities do climate mitigation planning? This is where communities reduce their greenhouse gases. They typically set a goal, which at this point should be net zero by 2030 or net zero by 2050. There's a internationally developed and accepted protocol for measuring community greenhouse gases. So do you measure, if you think about all the systems that are interacting, you think about your transportation system, your supply chain, how much air travel is your town reliant on? How should you count that? So part of the whole development of climate mitigation is that international associations of municipalities got together and agreed on a way to count who gets to count what greenhouse gas emission and who gets to count what way of dealing with greenhouse gases, and then plan for their resources. Part of the reason that I chose to use this Phillipstown, New York example is that there's a discussion about how they can use or not use the forest carbon capture in their town based on this protocol and based on international standards. And so I felt that this example of planning for net zero by 2050 was very relevant to communities in the North, because how can you count your forest carbon storage? So that's a basically how they do it kind of approach. I could have included more resources. You know, what the global climate protocol is to measure community greenhouse gases. I will say that they summarize how much they're using, how much buildings use, how much transportation uses, and how much industry use in different sort of scopes of measurement. And it is amazing how much energy consumption is currently the buildings share is. When we think of transportation as being quite large, and in many communities it's like 30 to 60% of the greenhouse gas emissions are in transportation, but buildings are usually an equal share. So one of the things to watch for when you're looking at how municipalities are planning on reducing greenhouse gases is are they focusing just on how the new buildings will be, or are they focusing on how to get the existing building stock to use less energy? Anyway, so I leave you with the Phillipstown, New York example. I would recommend that you well, I liked listening to the webinar because they had a conversation there. You could tell they were arguing about the forest, and I found that very interesting. Community climate adaptation planning. Many people just call this resilience planning. I put a couple of resources on Blackboard that have to do with climate adaptation planning in British Columbia. So there was from about 2009 till the present, various communities are doing adapting to climate change plans. And so they're assessing what their climate risks are likely to be, which is typically floods, wildfire, and heat, and depending on where you live in the province, and planning for how to adapt to an uncertain future. So identify the risks in this community that are associated with climate change, and then develop strategies to adapt to those changes and reduce the impact on the community of those changes. So that is my big picture lecture on this section. I am relying on you having some knowledge of climate change and what it is. And if you want me to post any other resources about that sort of basic, the basics of it, I can do that. Let me know by email. I think you'll find in the assignment that you guys will be, I'm asking you to find what is a global impact, or not global, what is the regional impact forecasts of changes due to climate change in the North. You'll need those for your scenarios. So thanks, and have a wonderful week.